So, part two of this lecture is now going to continue on with this kind of history of the development of evolution by natural selection, this theory of natural selection. Scientists have long noticed an array of biological diversity and that organisms are uniquely adapted to their environment. So, the real quandary was determining the method by which this diversity, this adaptation has arisen. And so natural selection is the method that we are going to talk about, that is the mechanism for both the emergence of biological diversity and the change through time of how species look, of the many forms that life can take on this planet. And so we have here a picture or a comic from Gary Larson, who had penned The Far Side. And I really like both Gary Larson and or The Far Side and Bizarro for their commentary on science and scientific principles. So we've got the wolves deciding which sheep they want to be present, to parent or father, to procreate, to generate the next generation of sheep. And so they're picking off the ones with characteristics that they don't find desirable and leaving the ones that they want to reproduce. So if you've read your introductory chapters from the Trivers book, and I apologize for the poor quality of those scanned-in chapters. It's a hard book to gain access to because it is an older volume from 1970s. We're talking about 40 or more years old. So just do the best that you can reading that material. We'll talk about a lot of it, of course, in these lectures. Trivers noted that organisms appear to be designed to do particular things, and Trivers specifically utilizes the herring gull to demonstrate this point. And so the herring gull is very similar to seagulls that you might find in any coastal area in the United States. So if you've been to either the Atlantic or the Pacific Ocean, if you've been down on the Gulf Coast, you've probably encountered seagulls. If you haven't ever had the chance to be on the coast, then you have probably seen Finding Nemo. And so herring gulls, like many other species of gulls, are very much like the birds that Nemo encountered as he got into the harbor in Sydney. And so this mine kind of noise and the loud raucous behavior is characteristic of most gulls. So the herring gull specifically is found throughout the year in the UK, around coasts and inland around rubbish tips, fields, reservoirs, and lakes, so pretty much anywhere that there's water. They breed often in colonies on coastal sites around the UK. The beach in the UK is kind of like the beach in Oregon, Washington. It's very rocky. It's not beautiful, pristine, sandy beaches with turquoise water that you might find in the Caribbean. And so the fact that they're colonially breeding on rocky shores is of critical importance. What we find with herring gull reproduction is that their nests will be spaced evenly. And we have to ask ourselves, what is the adaptation here? Why don't they cluster their nests together? Well, herring gulls have a pretty high rate of cannibalism. And so if you put your nest too close to your neighbors, then your chicks are probably going to be eaten by your neighbors. The male will feed the mate while she develops the egg, and the couple will mate repeatedly before the eggs are laid. What is the benefit here? Well, this feeding behavior is called a nuptial gift. We find this among a lot of species where males have to make some kind of indicator of their commitment to be a parent by gifting a prey item, gifting food, gifting a spermatophore, we find that in insects, to the female before the female will ever allow the male to mate with her. The benefit of mating multiple times, birds can store sperm in their reproductive tract, females in particular. So by mating multiple times, it raises the likelihood that competitors' sperm is displaced and that the male that is in fact committing to this parental investment behavior is the father of those offspring. The pair then takes turn feeding and brooding, so the eggs are rarely left alone. In a situation where you've got cannibalism of eggs and of young chicks, not leaving the chicks alone is critical for their survival. So you don't want your eggs to be picked off, you don't want your chicks to be picked off, and so you take turns going out to eat, where the other parent then stays and broods those eggs, keeping them warm. The pair develops a highly vascularized brood patch to transfer heat to the developing eggs. So there's an area on their underbelly that is devoid of feathers. And this area is highly vascularized. It has a lot of blood flow to the area so that it allows for a more effective transfer of heat. This bald patch on the belly is going to more effectively transfer heat to the chicks instead of having to pass that heat first through a covering of feathers and secondly through the shell of the egg. Herring gulls lay 3 eggs. These are laid so they all hatch synchronously at the same time. This maximizes the total surviving offspring. The eggs are speckled and gray to match the background. Well, why don't herring gulls lay 4 eggs? If herring gulls lay 4 eggs, then each egg is smaller than if they lay 3 eggs. The smaller size of the eggs is associated with a higher likelihood of failure of both the eggs themselves, not resulting in chicks that hatch, or the chicks themselves because they're too small when they hatch. The benefit of hatching synchronously is that in many species of birds, if there's asynchronous hatching, the firstborn offspring will somehow cannibalize or kill the other eggs before they ever hatch. So they may push the eggs out of the nest, they may poke holes in the eggs and then eat the developing chicks that are inside. Whichever behaviors they demonstrate, it's effective for removing competition. And so you want your eggs to hatch at the same time if you'd like for there to be no competitive advantage of one particular chick. So by hatching at the same time, each of the chicks are approximately the same size. None of the chicks are able to kill their siblings. And then, of course, the speckled and gray coloration matches the background so that any kinds of avian predators circling to try to get gull eggs aren't going to be able to see the eggs as like a stark white against this gray background of the rocky shore. Chicks have distinctive head patches that facilitate parental recognition. What this does is helps to prevent any wasted parental effort. And so parents are going to bring back food that they've chewed, that they've partially digested to feed to their chicks. They don't want to waste that effort on chicks that are not theirs. They want to ensure that the chicks they are feeding are in fact their biological offspring. And so those distinctive head patches facilitate paternal recognition. The chicks are not left alone until they're about 3 weeks of age when they can resist predation. This is going to minimize both chicks that are lost to predators as well as chicks that are lost to conspecific cannibals. So for these first 3 weeks, one or both of the parents will always be present to be able to fend off any kinds of attempt to kill their chicks. Parents have a red spot on their beak that the chicks peck at, which stimulates the parents to regurgitate food. This red spot on the beak is very noticeable, and as repeated pecking there stimulates regurgitation so that there's a more effective transfer of food from parent to offspring. So together, all of these behaviors effectively facilitate a greater degree of survival. And so from this standpoint, it appears that herring gulls are uniquely adapted to facilitate the survival of their chicks. When we look at the outcome of herring gulls ringed at hatching on the Isle of May in 1968, we find that only about 43% of chicks actually reach fledging. And so fledging is this period or this point of time in which chicks are able to leave the nest and then eventually go on and reproduce on their own. And so we have a very high rate of chick loss, and some of those are through cannibalism. 23.3% of chicks are cannibalized. Some are dead with head scars, some are dead with no visible injury, some are not accounted for, likely taken off and eaten by predators. So the mechanism by which natural selection operates is mortality, a high mortality risk, both through cannibalism and through predation. And so it should not surprise us that chicks appear to be uniquely, and herring gulls as a whole appear to be uniquely adapted to reproducing in this kind of environment, because we would expect that these selection pressures have been pretty consistent over their evolutionary history. And so herring gulls that demonstrate adaptations that allow them to resist predation, that allow them to resist cannibalism, are more likely to go on and leave surviving offspring that will reproduce in future generations. So evolution by natural selection is what we seek to describe, what we seek to explain. And how do we define evolution? Well, the most simplest base definition of evolution is simply a change in gene frequencies over time. And natural selection, therefore, would be the process by which gene frequencies change over time. This is not necessarily a controversial term. We don't get up in arms at the idea that evolution entails changing gene frequencies, right? We recognize that gene frequencies do change over time. So what then is the controversy surrounding evolutionary theory? Well, it is this idea that not only do gene frequencies change over time, but that these speciation events occur. And so what people really have a problem with isn't changing gene frequencies, but the idea that man evolved from monkey, or more specifically, humans evolved from proto-human, proto-ape ancestors that lived sometime 5 to 7 million years ago. And so it is this commentary on humans' existence that really bothers people about evolutionary theory. Evolution by natural selection produces characteristics of our behavior generating systems. And so this includes the human nervous system. Really, what guides our behavior is our exceptionally large brain and how we use it. And so our brain evolved through natural selection, just like any other physical trait. Our endocrine system evolved through natural selection. Why do we say our endocrine system is a behavior generating system? Well, because of the effects of hormones on human behavior. Like, for example, if you can remember back to puberty, to adolescent development, you will note that there may have been a pretty rapid shift from you having no interest in reproduction, whether that's with same-sex or opposite-sex individuals, and that point where you do have sexual desire and the interest in reproducing with either members of the same sex or members of the opposite sex, that interest in sexual behavior. And so that memory of how that sexual desire emerged indicates that strong role that hormones play on shaping human behavior. So to answer this idea of how could evolutionary theory be relevant to studies of human behavior, particularly when behavior is so flexible, we have to note that because of the fact that the anatomical features that help to, the morphological features that help to generate behavior have been subjected to natural selection, and that it can imply that behavior, therefore, has been shaped by natural selection, even among humans with large brain sizes and very flexible behavior. We note that Charles Darwin is the name most commonly associated with the theory of evolution by natural selection. And so we'll start with just a little bit of historical context about Darwin himself, and then we'll go on to talk about the specifics of evolution by natural selection. Charles Darwin was from an upper-class family. He went first to Edinburgh to study medicine, and then on to Cambridge to study theology. So he wrestled with this reconciliation of what science showed him, and scientific explanations for things and theological explanations for things. So Darwin was a devout Christian, a believer in the Christian God, and so these same kinds of moral dilemmas that may face any of you who subscribe to modern organized religion also plagued Charles Darwin. After graduation, he joined the HMS Beagle as a ship's naturalist on a voyage that lasted 5 years that effectively circumnavigated the globe, so from 1831 to 1836. What a naturalist did during this time was basically killed species that he came across and stuffed them. And so the idea of being a ship's naturalist was really focused on generating a collection that you could then take back to museums, to your own research laboratories to be able to study at a later date. So the quality of this image is bad. You note that this started out from England, went south around the tip of South America, stopped at the Galapagos Islands, which are clearly marked here off the coast of Ecuador, and then on around Australia and the southern end of Africa before returning home. Some of the key observations that Darwin noticed from his voyage were that many fossils resembled modern forms with slight differences. Fossils had been discovered throughout mainland Europe, throughout North America, and so there was a lot of debate as to how those fossils got there. Were they evidence of a catastrophe, catastrophism, like the Great Flood that Noah was supposed to experience, or were they earlier forms of modern forms of life? He also noted island zoogeography. So, for example, there are many birds on islands, but no frogs on islands. Well, why is that? Birds can get to islands by flying, so we've got an ease of colonization. Frogs can't get to islands by swimming because they're amphibians and they absorb their tissue. Their skin is porous and absorbs it would absorb the seawater and effectively dehydrate them. So we don't see very many amphibians on islands unless they've been introduced there in a colonizing kind of situation, like they've been brought ashore by boats. We find that island species are similar to their mainland species, but there are fewer species present on islands, and this is because of the difficulty in actually reaching those islands. We do also find reptiles on islands because reptiles can swim in ocean water. Mammals, it really depends on the size of the mammal as to whether we find them on islands. He also was intrigued with pythons that he found, particularly because they possess little tiny leg nubs and had a pelvis that was still present but was completely non-functional. And so why would a python have a pelvis if it didn't evolve from or form from an earlier species of reptile that happened to have legs? The Galapagos Islands are Darwin's most famous stop. They are off the coast of South America. They belong to the country of Ecuador. The Natural History Museum here in Albuquerque has recently had a film, a Dynamax film that deals with the Galapagos. They're a really diverse area. They're volcanic islands that are constantly in flux, with new islands forming and old islands disappearing. They have plants and animals that are very similar to South American species, but they also have some interesting differences. And of course, here we have a tourist with one of the Galapagos tortoises. There's been some recent news regarding the Galapagos tortoises that they've reproduced for really the first time in about 150 years. So that is good news coming out of the Galapagos. Darwin was especially interested in the bird life that he found on the Galapagos Islands, and these birds happen to all be finches. Here is a print from one of Darwin's own drawings of cactus finches, and here is a great picture that really summarizes what was going on the Galapagos Islands with these finches. So Darwin actually didn't realize that all of the birds that he had were finches, because the generalized finch beak is really a beak somewhere like this. So this third red specimen that has this kind of low profile, small, generic beak. And so this is what we might see in Albuquerque for like house finches or goldfinches, which do come to feeders here in Albuquerque. Um, and so some of these other birds he posited were completely different taxa. So if you look here at these bottom birds with this really thick, robust beak, that beak is adapted to breaking open things that have a really hard shell on them. So nuts or very thickly husked seeds. And then look at these beaks, like the gold bird in the middle here with this long curving beak. What do you think that serves? What kind of function does that kind of beak serve? Well, it's tubular in nature, and it allows these birds to get at nectar that's in tubular flowers. So it's very similar to hummingbird beaks. And so Darwin thought he had several different taxa of birds, and he stuffed these specimens. He brought them home, and one of his friends came by, and basically, the gist of the conversation in a nutshell was, "Hey, Darwin, those are nice finches." And Darwin was like, "Well, wait, what? These aren't all finches." And his friend was like, "Yeah, they are. Look at these other characteristics. Look at the tails, look at the eyes, etc." And Darwin was just like floored, blown away that these were all, in fact, very different beaks, but all the same taxa. So Darwin noticed that island birds change in character when they have competitors that live on the same islands. And so the nature of the Galapagos is that islands are constantly forming. They're small when they first form. They get larger as more eruptions contribute greater landmass. They'll reach their peak at several hundred years old, and then they'll start to erode away and go back into the ocean. And so islands vary in size, islands vary in age, islands vary in plant life that's on those islands. And so the more species that are present on the islands, which you find with these larger islands that are kind of in prime age, prime condition, the more specialized you'll see the beaks. On small islands that either had just recently formed or that were in the process of disappearing, you will only see a generalized beak shape, particularly if you only have one species present. So it was that very competition that allowed for this diversification of these beak types. And so the way when we think about competition, feeding competition, we note that there can be one of two outcomes when you've got multiple species competing over the same resources. One is that, well, I guess there could be three outcomes. One is that they all compete with one another and they all suffer higher mortality, lower reproduction because of restricted food resources, and they all fail. Another outcome is that one may have a slightly better competitive advantage and is able to outcompete these other species, and they kind of win everything. This is what anatomically modern Homo sapiens did once they evolved in Africa and came out of Africa and spread across the rest of the world. Or you can have divergence in traits that allow you to operate or occupy different ecological niches. And this is what is going on with Darwin's finches. That because of that high degree of feeding competition, we have specialization of beak shapes. And so one way for multiple species to inhabit the same space is to utilize different food resources. And so here we have finches that have beaks that are very much like hummingbirds, and they utilize a resource that's very much like hummingbirds, these tubular shaped flowers that it's kind of hard to get into and get to the nectar. We have finches that have beaks like a grosbeak. That's that robust beak shape kind of at the bottom, where you're cracking into like whole nuts and such. And so that allows them to specialize and focus on a very different kind of plant resources. And then we have these finches that have this generalized beak shape that makes them very effective at eating just generalized finch seeds. And so we see on the largest islands where there's much more competition present all of these expressions of beak shape, and that what it does is it minimizes feeding competition so that all of these birds can live and reproduce. Darwin was influenced by Thomas Malthus. who wrote an essay on the principle of population that brought two ideas to the forefront. So Malthus was also devout. You'll find that this period of scientific discovery, that many of the people who were scientists were also theologists, were also very devout Christians, and so part of part of what drove their scientific inquiry was helping to explain questions as to perhaps why God would allow certain things to happen. And so Malthus was plagued by the tragedies of the poor, the idea that God would love us so much that, but yet allow so much suffering. And what his essay brought to the forefront was the idea that populations have infinite fertility. That is, that we can reproduce in great numbers and rapidly increase our population density, but that environments are characterized by having limited resources. And so this introduces that struggle for existence, the idea that the impulse to multiply can be almost infinite, but there's going to be competition that leads to differential reproduction. That we have a kind of a system of checks and balances in place where we aren't going to reproduce exponentially, because if we do reproduce exponentially, then we also have a big uptick in mortality precisely because of these limited resources. And so this kind of set the stage for the kind of competition and differential survival and reproduction that natural selection invokes. And so by 1838, Darwin had come up with a theory as to the mechanism that might explain how species change through time to make them appear fit to their circumstances. He coupled his theory with Malthus's principles of population demography, that the population can expand infinitely, but the ability of an environment to support populations is finite. So as long as there's variation of organisms within a population, and that variation affects the abilities of individuals to survive and reproduce, and is also heritable, then we'll have natural selection. So Darwin noted that that organisms do vary. They vary in the traits that they possess, and that variation then affects oftentimes one or the other when looking at survival and or reproduction. He also noted that it is traits that are passed or transmitted from parent to offspring that have that are much more strongly selected either for or against, depending on the adaptive nature of those traits. And so this brought up that component of heredity and these kind of discrete units of inheritance that may influence how natural selection operates. And so Darwin coined the term natural selection for the process where traits that confer advantages in survival and reproduction are retained in the population and passed on to the next generation. So now we've kind of got two working simplified definitions of evolution. We've got change in gene frequencies over time, which is essentially what we're measuring. We've also got this idea of descent with modification, that we will see characteristics change from generation to generation based on what works well in particular environments. So this, all of this work that Darwin was doing, others were researching evolution as well. And Alfred Russel Wallace got really the short end of the stick here. He got the shaft. He was a correspondent of Darwin's and sent Darwin a paper in 1855 suggesting that species were descended from other species and that the appearance of new species was influenced by the environment. That is, basically, that the environmental shifts create this situation of natural selection that then shapes the direction adaptation takes. And so he sent a copy of this manuscript to Darwin and asked him basically to give him some feedback, and they communicated back and forth, but Darwin really beat Wallace to the punch. And so by receiving this manuscript from Alfred Russel Wallace, his friends urged him strongly. They're like, Darwin, you've got to publish this stuff because otherwise, look, this young bloke is going to come and kind of usurp your ideas and get the fame for it. And so in 1859, Darwin published On the Origin of Species by Means of Natural Selection, or The Preservation of Favored Races in the Struggle for Life. He had one sentence in there in the first edition: much light will be thrown on to the origin of man and his history, that was later removed from the book, but it was too late. The damage was already done. In The Origin of Species, Darwin actually doesn't talk about human evolution. He talks about the idea of natural selection resulting in differential survival and reproduction. He talks about how speciation events could occur, but he doesn't actually talk about this process whereby humans arose. It's just that one sentence from the text really led to this division between science and religion, and this controversy. And Darwin suffered greatly from this controversy. He was faced excommunication. He really lost a lot of his faith, just based not on religion itself per se, but the treatment that he received after publishing his book. And so, we even see this phrase "favored races," and this leads to another kind of misapplication of Darwinian theory, and that is to the topic of human race. Of which we don't have distinct races. They're not biological categories. They are entirely culturally constructed. But many people who have a kind of an impetus for prejudice and discrimination and want to, for whatever reason, subject other populations, perhaps to get to their resources, etc., they've used this term and talked about how whites are the quote-unquote favored race. There have been many misapplications of Darwinian thought. And so Darwin's theory of evolution by natural selection has to have a couple criteria met. First, there has to be variation in a trait. If there's no variation, there's nothing for natural selection to operate on. Secondly, this variation has to be heritable. So I'd like you to think, do any of you have tattoos? I have a tattoo of Curious George on my back. I've got another tattoo on my side. My kids weren't born with tattoos, right? Just because I have a tattoo, it bears no influence on whether they will ever have a tattoo in their life. So that is variation that exists, but is not heritable. Variation that's, or think about people who've had amputations, right? Their children are not born missing limbs. So there can be a lot of variation that sets in. I mean, we talk about the effect of the environment and environmental toxicity on like cancer rates and stuff, right? Cancer is effectively a genetic shift. Cancer is effectively a mutation, but if it doesn't set in until after you've reproduced, and if it doesn't affect your gametes, it's not going to have any kind of effects evolutionarily, because it's not going to lead to to inheritance of certain conditions. So we can have mutations that set in. We can develop variation later in life that isn't going to be acted upon by natural selection. So we've got heritable variation. If that variation is associated with differential survival and or differential reproduction, it doesn't have to be both. It can just be one of those. Then there must be evolution by natural selection. So when we talk about differential survival, I mean, we can think of some extreme cases, right? That you have a trait that means you die by the time you're 6 months old. That is going to be very strongly acted upon by natural selection to weed that trait out of the environment, because people who possess that trait are never going to live to reproduce. But it's not always either or, dying or surviving. And so we can think about a trait that just confers a slight advantage or disadvantage in survival, so that you might live to be 90 instead of living to be 87. We've got this slight advantage survival-wise. Similar with differential reproduction, it doesn't have to be a situation of all or nothing reproduction, right? It doesn't have to mean that you either reproduce or you don't. don't. It can simply mean the difference between 3 children and 2 children, or 10 children and 11 children. So we're not talking about all or nothing distinctions. We're talking about just slightly different survival rates, slightly different reproductive rates. And so when there's evolution by natural selection, the most favorable traits are selectively retained in the population. When we talk about survival of the fittest, we're not talking about the strongest or the fastest in all situations. Think about the sloth, right? What's going to happen to the fastest sloth? Well, they're not going to be very successful because it's going to demand a metabolism that's too high for what the environment can sustain. So sloths are adaptively slow with a very low metabolism, so that this diet of really only leaves is able to be met and able to keep them alive. If they had the metabolism of, let's say, a mouse, they would have gone extinct by this point. So when we talk about favorable traits, we are talking about environmentally dependent favorability. Okay, so it is the degree to which that particular trait is suited to the particular environment that the individual possessing the trait finds themselves in.